Hello and welcome back to my channel. Today on the bench we have an Apple IIc CRT monitor. I have two of these cute little monitors. One used to work and then it stopped working, and another one that never worked. Now we can't figure out which is which, so I just picked one and all I know is that it shouldn't work. So I would say let's open it up and let's take a look. Now before we begin, the usual disclaimer when it comes to CRT monitors. Please don't open a CRT monitor unless you absolutely know what you're doing. CRT monitors are very dangerous. They contain very high voltages that can kill you, and the whole CRT tube, the picture tube, is basically a massive big capacitor, so it can shock you afterwards even though the power has been disconnected. Don't take this as a tutorial, and if you decide to open a CRT monitor, you do it at your own risk. That being said, let's open this up. I'm not familiar with this. I've seen some videos. Coincidentally, there's one of the YouTubers I'm following, Epictronics, have recently released a repair video for one of these things. This monitor has been disassembled before by its owner, who is a friend of mine, Hi Lee. But nothing has been touched on the motherboard, on the component level, because my friend doesn't feel comfortable working around CRTs, which is very much understandable. Not that I do, but anyways, I like to give it a go. Hopefully, it's not going to end up like my previous Apple CRT monitors, which literally took fire. Now, one downside of working on this model of monitor is that it's very compact, so everything is crammed in. That being said, I think, yes, the motherboard is accessible here at the back, and there's a very nice, very ingenious hinge system here. So I think the motherboard folds out, making repairs a bit more comfortable for the technician. Now, before I even begin touching this monitor, I've noticed something on the power supply section, which I'd like to show you. That is a reefer capacitor, and honestly, I'd like to replace it before I try to power up this thing, because I never had one exploding on me, and I'd like to keep on that trend, to be honest. Right, here it is. It's 100 nanofarad. It's an X2 capacitor, of course. This is where mains voltage is coming before it gets into, looks like a transformer for DC. Don't shoot me, but I'm going to replace this reefer capacitor with a reefer capacitor. The reason is I bought this reefer some time ago. These are brand new, they're not recycled, for another project. I think it was my other Apple IIe computer. Reason is I think I couldn't really find anything that had the same leg width, and fair enough, I could have purchased something different, much more reliable, that doesn't need much to be adapted, but I have a few of this, to be honest, and I spoke with the owner of this monitor. He's absolutely fine. He knows what the reefers are, and he's absolutely fine for me to use this, because in the end this is gonna last another 30 years, I guess. Especially on a monitor like this, to be honest, it's nice to have a like-for-like replacement. This is exactly the same size, it's the same height, it's everything. It's nice to have something that just goes straight in without having to worry about anything. Right, shall we give this a go? Again, there's nothing connected to it, and I'm ready to power up. In 3, 2, 1, go. Well, the monitor is completely dead, which maybe, hopefully it's a good thing, because that means maybe it's just the power issues. Now, without looking at the schematics or thinking too much about this, what I can see is mains power is coming here, and it's immediately leaving the board. So from here it goes to here, which are these two black cables which are going to this little board here where I replaced the reefer capacitor. Obviously there's some interference filtering here. Then from here it goes into the transformer. From the transformer through these red cables it goes back to the main board. So it looks like that's the AC coming from the transformer, and I do see 4 diodes here. So obviously we have some voltage coming here. The diodes are doing some rectification, and this is probably the main supply voltage of the board itself. So the first thing I want to do is, do I have a voltage getting into the board at this level, at this stage? And let's see if I measure anything here. There's no alternate current. Is there any DC? Obviously not. Do I actually have mains power going in? Yes. So we have mains, but simply we don't have any power coming from the main transformer. Now again, without looking at schematics, I think I'll have to have a look at that little board we just looked at. One thing I didn't check is the fuse. There's a fuse on it, and maybe that's gone, and that's the reason why the transformer is not getting anything. So here's the fuse I was talking about. Continuity mode. Let's check the fuse. Ah, the fuse is working. That's interesting. I'll look into the board a little bit, try and understand what it does. But from what I can see, it doesn't do much. So I guess the first thing I want to do, I want to make sure that we have continuity between the actual main socket here to where the mains is coming to this little board here. So let's check that out. So I got the meter in continuity mode, so it will beep when there is continuity. I'm touching one of the terminals here. Yeah, and we got complete continuity. If I'm touching the other terminal, which is going to be the black one, and it's full continuity, so that's great. Let's keep following the signal. I'm going through the black one, which I think is going through this fuse. Yes, and from this end of the fuse, it should go on the other end. Okay, wait, we checked the fuse yesterday. It was working. Is it not working now? Is it? Oh, wait a sec. There's something wrong here. Right, I might have found an issue here because the fuse holder is a bit loose, as you can see from here. I guess yesterday it was just, it was showing continuity by chance, but obviously this is not gonna work very well, I suppose. So what I'm gonna do, I'm gonna remove the fuse, tighten these clamps, and that should improve things. Okay, feels so much better now. It's still wiggling, not at all. So let's check for continuity, and it's working fine. I'd be tempted to try this again now, because that might have been everything that this monitor, well, at least the supply of this monitor needed. Before moving any further, I'd say let's give it a go and see if it works now. Okay, well, I'm ready to try in 3, 2, 1, go. The wrist power, LEDs is green. Not sure I heard high voltage, but it's a small monitor. Okay, well, I guess we can start measuring something. So do we now have AC voltage coming out of this thing? We do. I think it's supposed to be, at least the US schematics, they say supposed to be like 18 volts. We do have 18 volts DC at this capacitor though. So it looks like the voltage regulation of the units is working. Right, I didn't realize that the brightness adjustment is at the back. So that could be at minimum. Hopefully it's at minimum. There is something. Okay, well, let's grab a computer and let's plug it up. Right, to test this monitor, I got out my very own Apple IIe, which I repaired and restored before this channel was born, unfortunately. It was an interesting fault. It would have been nice to show you on video. But anyways, it's working totally fine now. I got the floppy EMU connected, and I'm going to load something and see if there's any picture displayed by the monitor itself. Okay, let's test this again, this time with an input. Let's power up in 3, 2, 1, go. Monitor is on. And let's turn on the Apple IIe and see if we get anything out of it. 3, 2, 1, go. We should see an Apple II something, and we don't. I see a raster, but we don't see anything. Aha! Look at that! The connector needs a little bit of attention. Actually, this picture tube is in great shape. It's very sharp and very bright. It's just amazing. Adjustment trimmers need a once-over, and obviously the signal input needs attention, so the next step is to remove the mainboard so I can also inspect all the components and all the solder joints. As I said, don't work on CRTs, but if you decide not to follow my advice, always remember to discharge the CRT after it's been switched off and unplugged. The CRT itself is a big capacitor, so you need to discharge it on the chassis, not on the electronics, otherwise you're discharging it through the electronics, and you might be able to see some sparks. Okay, well, I've inspected the board a bit, and the good news is I don't see any leakage or anything suspicious. One thing I'm noticing is all these capacitors are rated 85 degrees, which is kind of means that they're probably not the highest quality. I've agreed with the owner of this monitor that I'm not going to do a full recap. when you check online, it's always a very debated subject whether to recap regardless or not. I feel it doesn't hurt if you want to recap something which is 30 plus years old. It will probably last a bit more. But just out of curiosity, I've selected one capacitor, which is this one here, only because it's close to this heatsink. I'm assuming that's probably the horizontal deflection transistor. Just a wild guess in it. It's 1000 microfarad. Is it 25 volts or something like that? I have a replacement if it's needed. I'd like to remove it and just check it with my component tester and just out of curiosity see what that does, and then we'll move from there, to be honest. I've also checked the back of the board. All the solder joints look fine. I might redo the usual suspects, the ones of the diodes, for example. Obviously these diodes are getting pretty hot. I can see the PCB is discolorated a bit, and also I guess where the video signal is going in, because it's probably more likely to get some physical stress over the years. And this capacitor looks totally fine. There's no sign of leakage or anything, not even on the board. It looks totally fine. It is spot on, and the ESR is very low. So again, it doesn't mean that all the capacitors on this board are okay, but I don't know. I don't see evidence to justify replacing them, to be honest. And it looks like maybe I was right in checking the soldering joints, because I think I might have found an issue here. If you look at that Q701, which is coming from that little board where the power supply is, I think it's like a transistor which is looking after the voltage regulation. Let me see if I can show you if I'm wiggling the other side. That to me looks like a cracked joint, the base of the transistor. It's kind of weird because it was working before, but that definitely would have been an issue long term, or probably immediately after reassembling everything. There you go. Okay, it's time to fix the composite jack. As you can see, that's got a little bit detached. So the positive is connected, but the ground is not, or at least it's intermittent. Just put a little bit of solder on at the back here, if I can reach it. Okay, it doesn't move anymore. Now, let me double check I haven't shorted everything here, because again, I can't really see much there. Got continuity there. What matters is we don't have continuity between the signal and the solid ground. Perfect. So I guess I'll give it a clean. It's a bit crusty. See if I can improve it, can we make it a bit more shiny. I want to say it looks brand new, but that's pretty good. I'm pretty impressed. Look at that. Amazing. Right, let's do the same with these trim pods. And finally, a good general clean, since it's open, and we can do that. Right, okay, I think I'm done here, so I just need to reassemble it and test it. Right, okay, should be good to go. I've got signal coming in from the Apple II as before, so I would say let's power it up and see if it still works. In 3, 2, 1, go. And let's check all these controls now, whether they're still scratchy. They shouldn't. So that's the sync, and that's good. This is the height, and that's totally fine. And then we got brightness, which is fine. Plus we got contrast here, which is also very fine. Perfect! The final step on this monitor is to center the picture. This is done through these two brown rings installed around the CRT neck, which are actually magnets. Now, unfortunately, one of the rings is not very accessible, as the handle to grab it and rotate it is facing down, and there is no access there. So it will take a little bit of back and forth to get to a good result. Turning only one of the rings moves the picture diagonally, so it's not straightforward, particularly because one of the rings can be easily operated, so I had to switch off the monitor sometimes in order for me to stick a metal tool close to the neck and turn the inaccessible ring of a random amount and hope it would be the right amount. But in the end, I got there and I'm happy with the outcome. Right, the monitor seems to be working fine. I guess I'll have to use it a bit to make sure that everything is in order, but so far so good. It's really sharp, it's really bright. The only thing I can see is that the picture seems to have a little bit of keystoning as a trapezoidal, if I'm saying that right, shape. And the service manual doesn't say anything about adjusting that. I'm assuming it's not adjustable. If anybody knows any different, please do let me know. I guess this is just how the monitor was designed, to be honest. Now, I'm assuming that it hasn't taken too much to get to this point in terms of video length. So I would say, rather than ending the video here, why don't we go ahead and try and fix the other one? Because I happen to have another one, which is on my to-do list. Let's have a look at that one. And if I can fix it, fine. If I can't, well, we can give it a start and then maybe continue another time. Okay, well, this is the second monitor. I believe this might have been the one that used to work and then stopped working. I'm not sure about that, but I can see that something's been done to it because I can see the high voltage suction cup has been disconnected. I also see the fuse missing here and the neck board was disconnected already. I need to see what happened, so I'll just put it back together. But before I power it on, as with the other one, I'll just replace the reefer capacitor. Right, it looks like this version of the monitor has 3 reefer capacitors. Well, I guess the Apple engineers who designed the Apple IIe monitor were the same, because for that monitor I had a little bit of spares. So we got 0.1 microfarad, which happens to be 100 nanofarads. That's the same I used on the other monitor. And then I have these 2 small here. It says 4700 picofarad, which is 4.7 nanofarad. And I happen to have a 4.7 nanofarad because 4 and 7 is 4.7 nanofarad. So yeah, that's great. I got spares, so I can go ahead and replace these 3. Well, that's one of the reasons why I wanted the reefers out of this thing. This one, to be honest, I made it worse with my pliers, but it was cracked already, so they were both cracked and I guess ready to emit their magic smoke. So happy days. Right, while I was reassembling the monitor, I realized the fuse had been taken out. I guess that was my friend when he was troubleshooting. And I just tested this fuse and the fuse is actually blown. So I hope I have a replacement. I should have it. But the thing is, there might be something a bit more wrong on this monitor which caused the fuse to blow. So let me get a replacement for this one and I'll put it back. One other thing I'm noticing is the video input connector is loose, as usually happens with these computers. So again, that needs to be fixed, no big deal. For now, to be honest, I'd be happy just to see a raster on the CRT just to show that it actually works. Okay, right, I guess I'm ready to power this up. Ready to go in 3, 2, 1, go. Nope, this time this looks like a bit dead. So as we did with the other one, I would say let's start with supply. So I got the meter set to DC. On the other one I measured 18 volts on a capacitor here. So I want to see whether I'm reading anything. And I'm not. So it looks like we might have either the fuse is blown, which is totally fine, or we might have a supply issue. So let's see whether we have AC coming out of the transformer. We don't. So this is another issue with the main supply. I mean, do we get mains coming in? We do. Okay, so we got mains, but we don't get an output. So chances are the fuse is blown again. So let's check the fuse first. Right, the fuse seems to be okay. Now I did squeeze this holder here, so I'm not expecting to have the same problem we had before. What I can do, I can check from the back on the solder joints to see if there is continuity. And there is, so that doesn't seem to be the problem. I guess one thing that we can check is whether the main switch is working. I definitely left it engaged, but we can check whether it's actually working. Okay, so the switch is now disengaged and there's no continuity. And if I push the switch, I got 0 ohms. So the switch is working, and I do have continuity between the socket here, that where mains is coming in, and the switch. Now I guess I'll have to remove this little board again to see exactly what happens, but most importantly, the main transformer here is connected. There's a connector down below which I can't really reach from here, and that's where mains is going into the transformer. So I guess the next step would be to check whether there's actually mains going into the transformer. Okay, so that's the little board where I replaced the reefer capacitors. This is where the mains power is coming in. I don't know which is live, which is neutral, but that's mains, and the third one is ground. The red cables are the return from the main switch, the main power switch, and this T1 here is where the transformer, this one, is connected. Now, from what I can see, mains is coming through here, is going to the fuse holder, that's the fuse holder, and is going to the main switch. And the other leg is coming through here and is going to the switch through an inductor. From the switch is coming back through these red cables. And then you can see that one of the red cables is going straight to the transformer and the other one is still going to the transformer through the same inductor, basically. And then you obviously have capacitors and other things to remove interference and that kind of stuff. Now, to double check that everything is working, I think it's pretty easy. And I only have two hands plus the camera in the way. But if I'm checking between where the AC is coming, when main is coming, and where the mains is going to the transformer, I'm in continuity mode, and there's no continuity now, but if I switch it on, it's beeping. And if I'm checking on the other leg, on the other pin that goes to the transformer, again, no continuity now, and continuity now. So it looks like the transformer should be getting mains voltage, because I got continuity when I'm pushing the on-off button. This is where mains reaches the transformer. You can see it's going straight to the transformer. So that's the primary coil of the transformer. I've got my fluke in resistance mode. And we get what I would say it's a pretty healthy 98 ohms. I think I was reading the same on the other one because I was reading that whenever I was checking something that was this more or less 100 ohms. At this point, I would like to check the secondary coil of the transformer, which is going to the motherboard. So that's going to be these two red cables. As you can see, they're coming from the transformer. So let's see what we got here. No secondary coil. Well, that's really bad news. That is really bad news. I don't think there's much I can do. What I'd like to do, I'd like to take out this transformer and see if by any chance there's anything I can do where these red cables are connecting, but I believe it's going to be very, very unlikely. I was hoping that I could see a glimpse of continuity when bending the secondary wires around. That would have implied a breakage which could have been repaired, but no, I don't see the secondary coil at all. And to be on the safe side, I tried feeding mains voltage directly into the transformer, and unfortunately I had nothing out of the secondary. Okay, well, I guess unfortunately this power supply is gone. Now, given how easy it is to remove it, which I was totally not expecting, I thought I had to disassemble the whole thing, I'd like to get the other power supply from the other monitor, I'll install into this one and, just double check if there's anything that doesn't work, then I can fix the rest until, hopefully at some point, I get replacement for this. Now, just out of curiosity, let's see what the healthy transformer reads. And the primary coil is reading the same, 98 point something, and the secondary coil is reading 1.2. So yeah, the other one is definitely gone, unfortunately. Okay, so I got the working transformer into the monitor, which we don't know whether it's working or not. And I think I've got everything reconnected and I should have a signal coming from the Apple IIe. I'm ready to power up in 3, 2, 1, go. Do we have a picture? Well, we do, but not exactly what I was expecting. There is a raster, but it's all messed up. Let's stop this connector here. Look at that. It was just So this monitor is working. It's just it needs a new transformer. Amazing. That was, I would say, another easy fix. Unfortunately, this one is not something I can fix easily without a spare part or without getting creative and finding another whatever voltage this transformer is. Actually, since we are here, I would say let's measure the voltage that comes out of that transformer. So maybe I can have a look online and see if I can find the replacement. So I'm in AC volt mode and I'm reading 16 volts. So I need to find either an exact replacement or a 16 volts AC transformer. I'll take a look, I guess. The next step for this monitor, well, we definitely need to fix that signal input because it's obviously pretty dodgy and that needs to be fixed. And as the other one, what I'm going to do, I'm going to remove the board, the main board, and just inspect it, redo some soldering joints, make sure there's no capacitors obviously leaking. But to be honest, this is another very bright monitor and it looks pretty good. One thing this monitor might need, which is not going to be obvious on camera, it might need a little bit of rotation of the yoke, because I can see the picture is slightly rotated clockwise. It needs to go counterclockwise a bit. But that's definitely the last thing that you want to do. And for now, let's switch it off, discharge it, fix that signal connector, or obviously service all the trim pots around this monitor, and then inspect the board and see if there's anything that we can do to make it happier, and then we'll move on. And as with the other monitor, I'll check this capacitor here as a representative of the health status of the whole board. And no, this is spot on. It's literally spot on, because again, remember the electrolytic capacitors have a 20% tolerance, so I'd be happy between 800 to 1200. And this is 1031, ESR is very low, it's totally fine. I don't see really reason to replace these capacitors. Besides long-term reliability, it's always a good idea, but I think I'm happy with the board as it is. So as before, I got the Apple II outputting something, and I'm ready to power up. In 3, 2, 1, go. Okay, well, it still works, it's great. Let's check this connector. Totally fine, totally stable, that is great. Now let's put on a test pattern and see what we got. Right, exactly as the other monitor, which is kind of weird. The picture is too high. This is also rotated clockwise, so it will need to be rotated counterclockwise a bit. To adjust the rotation of the picture, I'll have to rotate the yoke of the monitor. The yoke is the whole assembly with all the copper coils installed at the neck of the picture tube. The electron gun at the end of the neck is shooting electrons in a straight line, so it's the yoke's responsibility to guide those electrons through appropriate magnetic fields so that the picture is actually drawn on the face of the CRT. Without the yoke, you would only see a very bright dot in the middle of the screen. First, I'll have to loosen the yoke itself. Then, wearing a rubber glove, I can rotate it so that the picture is level. Once I'm happy, I can tighten the clamp so the yoke doesn't move anymore. And finally, I can center the picture exactly as I did before with the other monitor. Same process, it takes a little bit of trial and error to get to a good outcome, but the final result is good. On this monitor, I also played with these little magnets installed around the neck of the tube. Those adjust the geometry of the picture, as you can see from this sped up footage. Each of the magnets affect the geometry of a small section of the picture when rotated, and they also interact with each other. Unfortunately, the magnets located close to the board are really not accessible, so I couldn't really do much. I'm not sure I managed to improve the geometry, but it was nice seeing them in action. Now I'll have to find a solution to replace this faulty transformer. Now I believe I have two options here. First is to replace this transformer with another one that fits in this cavity here. But before I go for that option, I'll have to find out the no-load voltage of this transformer itself, which is very easy. I can just use my multimeter, and it's 18 volts. So this is an 18 volts AC transformer. Then I'll have to find the current drawn by the monitor, because I need to properly specify a suitable transformer. Now that's a bit more complicated, but not the end of the world. I will have to use my multimeter. I do have a current clamp, but it's rated for like 200 amps and it's not very accurate at low currents. So with the multimeter, it has to be in series with the output of the transformer. And here I got one leg of the output connected straight to the board and the other one going through the multimeter and back to the board via these alligator clip lead. It's a bit precarious, but it's low voltage, so it's okay. And when I power up the monitor, the reading is up to 1.83 amps at maximum brightness and contrast, and the voltage is 16 volts, so we're talking about 29 watts here. Now, I had an extensive look on the Mouser catalog for suitable replacement transformers, and the most powerful transformer that I could find that would fit into this cavity, it's only 24 watts. So this doesn't really feel like a viable option. Also, I'll have to consider electromagnetic interference, because this transformer, it's only a few centimeters away from the neck of a CRT picture tube. And obviously we don't want any interference, any magnetic field going around a CRT tube. Now, the original transformer, as you can see, it comes completely shielded, enclosed into this metal case, plus there's this metal ring around it, which I guess is for added insulation. Now, I can't find this off the shelf, it's not something I can buy. I am pretty confident that any transformer that I'm going to install into this little cage here would somehow affect the picture tube, making the picture wave, which obviously it's not acceptable. So honestly, I don't think that replacing the power supply with something else is a viable option. Option number 2, which is the one I'm going to take, revealed itself after I had a look at the schematics. Let me show you what I mean. So this is the whole power supply section of the monitor. You see that you got mains coming in here, it's going through some filtering, and then it's going through the transformer, which has failed, outputting 16 volts AC as we measured. Then we have the rectification, we have some smoothing capacitors. The voltage is going into these voltage regulator, which is an L123CB or C8. This voltage regulator is using this transistor, an external transistor, to regulate the voltage to 12 volts. You can see here the output of the transistor is 12 volts. You got 18.8 going in, rectified, and 12 volts coming out. 12 volts coming out. We got a 1.5 amp fuse, and that's it. I mean, this is where the power supply ends. And then these 12 volts are split into different voltages, which are going to the rest of the motherboard. Now, if I removed this fuse, I'm effectively isolating the whole power supply from the rest of the board. So this whole power supply only has one voltage coming out of it, and it's 12 volts. So this monitor is a 12 volts DC monitor. So knowing that this is a 12 volts DC monitor opens up a lots of possibilities. One option could be to fit a DC power jack at the back and just use an external power brick, a 12 volts power brick, to just power up the whole monitor. Or I could even use some voltage coming from the Apple IIc itself or from the Apple IIc's power supply, so you only use one. Now, to be honest, I'd like to keep this monitor as regional as possible. If I can't replace the transformer, I don't want to start drilling things around it. So instead, I'm going to install a 12 volt switch and power supply. Now, switch and mode power supplies have gone a long way over the past 40 years, so nowadays I can find a very small power supply delivering all the power that I need. But first, I'd like to make sure that my plan works, so I've connected my bench power supply to the 12 volt line of the monitor to see if it works. I've lifted the fuse, so I'm injecting 12 volts exactly where the existing power supply would do the same. And I'll start the bench power supply now. And it works, that's the picture, everything seems to be totally fine. And would you look at that, only 1 amp at 12 volts, which is 12 watts. So the remaining 16 watts were dissipated by the power supply section itself just to function, just to work. So this plan seems to be working, and also I'll be reducing the power consumption of the monitor itself. This is a good quality Delta Electronics 40 watts 12 volts switch and mode power supply. As you can see, it's very small, but it has all the power that I need to drive this monitor. What I'm going to do is to install it where the existing transformer used to be, and then I'll route the 12 volt output just before the fuse to power up the rest of the board. I'll drill 4 holes on this bracket, and then I'll use these plastic standoffs to install the power supply onto the bracket itself. I'll also add all the necessary connectors so I don't have to solder anything permanently in place. Then I'll have to sever the existing power supply section so that I'm not injecting 12 volt back in the output of the voltage regulator. To do that, I'm going to cut a trace here on the motherboard so that basically the voltage is not going back into the voltage regulator. It's probably not necessary, but I think I'm going to do that anyways. Right, not my best job, I'm afraid. The top part is totally fine, even though I shouldn't have purchased the standoffs with these wings, because they are kind of in the way and they come out of the PCB on the edges, obviously. At the bottom, I'm afraid I made a mistake when I drilled the holes, and it was a bit too late when I realized the standoffs don't really fit tight in here. Not the end of the world. Again, this will never touch the ground plane here, and I'll put a little bit of glue on this end so that it doesn't come off for whatever reason. That being said, again, it feels like it's designed for this bracket. About these two cables leaving the board, the one on the left goes to the regulating transistor, which was attached to the chassis, and the one on the right to a high power resistor, which can be found on the mains input board. Those were part of the voltage regulation section of the board, so they can be disconnected for good. Right, so before I go on and connect the power supply to the board, I'd like to make sure it works. It's a brand new one, also want to make sure I haven't done anything wrong in here. There is power going into the monitor, but it's basically going to the power supply and then output here, so the rest of the monitor should be completely isolated. Got multimeter in DC mode, and I'm ready to give it a go. In 3, 2, 1, go. It's perfect, the polarity is also okay, and it's exactly 12 volts. So let's go ahead and connect this to the motherboard. For the ground output of the transformer, I decided to hijack this existing ground wire. I simply desoldered it from the board, soldered the power supply black lead around it, protected with some heat shrink, and then solder it back. For the positive wire, I decided to solder it on the fuse holder itself to what looks like a tab designed to solder wires on it, so it doesn't look too untidy. And finally, I cut the trace on the board so that 12 volts is not going back to the voltage regulator. Okay, well, the monitor is back together and I got the Apple II running a test chart so we can check whether it's working straight away. I'm ready to power up in 3, 2, 1, go. We got a green light here, which is a good sign. Yeah, it's working, look at that. It's amazing, fantastic. So that worked. Now, before we continue, I would say let's double check that the 12 volts, it's actually 12 volts, that it's being regulated correctly. 12.04, so it looks like it's been regulating perfectly fine. Okay, I now have a full, white green screen. I'm curious to see whether the voltage stays regulated to 1204. And it does. I don't see any issue whatsoever, as you would expect. Again, the 12 volt line was only 12 watts and this power supply is 40 watts, so obviously that's not going to be a problem. As a final step before wrapping up, I'd like to change the way I install the power supply on the chassis. I really don't like those plastic stands. Also, I stumbled into the Delta Electronics datasheet for this unit, and it does recommend to install it on grounded posts for the best EMI reduction. I did notice the fixing pads were connected to ground via a 1 mega ohm resistor, so this is what I'm going to do. And the outcome is great, I love it. It looks so much tidier and professional. Well, I guess I can now put the monitors back in their plastic cases and consider this project completed. Right, we reached the end of the project. I fixed 2 Apple IIc CRT monitors and I really enjoyed doing that. Now, I have repaired another Apple CRT monitor in the past. You can find the link down below in the description. And I have to say, I'm not sure I enjoyed that monitor as I enjoyed this one. I mean, that monitor literally caught fire. If you haven't watched the video, I would definitely recommend you go and watch it. Now, I'm not saying that these are safe monitors. There's no such thing as a safe CRT monitor. But especially when I realized that these are 12 volts monitors running at 12 watts, it felt a bit more safe, let's put it that way. I still need to pay quite a lot of attention and make sure I'm staying away from high voltage and mains, but besides that, after the transformer, it's a very low voltage thing. They're easier to turn around, they're easier to poke on the board and scope signals and everything. So I thoroughly enjoyed the process. I also enjoyed refurbishing them, fixing all those little things with the board and also finding a replacement power supply for that monitor. And I'm really happy with the outcome. It looks pretty nice. And yeah, it feels like a Frankenstein monitor with some modern parts inside, hopefully working for many years to come. So that's it for today. I hope you enjoyed this video. If you did, I would really appreciate if you could hit the like button down below and also consider subscribing to this channel if you like this kind of things. For now, thanks for watching. I wish you a great day and I hope to see you again soon here on this channel for my next videos. Thank you very much and goodbye. Bye.